Welcome to the deep dive. Today, we're diving right into machine communication protocols, or MCPs. These new open protocols, mainly coming from Anthropic, are really changing how large language models, LLMs, can connect with, well, real-world apps and services.
Yeah, it's basically giving AI a standard language to actually use things, not just talk about them.
Exactly. And what's really striking is how fast this is catching on.
Oh, absolutely. You've got major players jumping in already. Windows Copilot, Google's Gemini, plus OpenAI and Claude were already kind of supporting this direction.
So it's not just some fringe idea. It feels like it's quickly becoming maybe the way apps will talk to AI.
It really looks that way.
Yeah, which means, for anyone building apps or services now, understanding MCP isn't just interesting. It's becoming, well, pretty essential if you want LLMs like Claude or ChatGPT to actually use your stuff. So our mission today for this deep dive is to get past just what an MCP server is. We want to dig into how to build one the right way. And we've got some great insights based on work from an expert at Neon. They're a serverless Postgres provider, and they've been right in the thick of this.
Right. So, okay, what actually makes up an MCP server?
Yeah.
Fundamentally, you're looking at three main concepts it presents to the LLM. You've got tools, resources, and prompts.
Okay. Tools, resources, prompts.
Yeah. And while they all matter, the real core of it, and what we'll focus on mostly, is tools. That's where the action is, so to speak.
Tools. Got it. So when we say tools here, we're not talking hammers and wrenches, right? What are these?
No, definitely not. Think of them as specific actions the LLM might want your app to do. So if you're an online store, a tool could be add this item to the cart or maybe complete the purchase. Or for Neon, since they do databases, a really important tool is naturally create a Postgres database.
Okay, that makes sense. The LLM uses these tools to get things done via the application. You mentioned seeing Neon's MCP in action. Can you give us an example? Like, how does that actually look?
Sure. There was this neat example where a developer using Cursor, which is an AI-powered code editor, wanted to build a simple to-do list app.
Okay.
And their prompt was pretty straightforward, something like, build me a to-do list app, use Neon Postgres, and use Neon OL.
Just like that?
Pretty much. And behind the scenes, Cursor acted as the MCP client. It talked to Neon's MCP server, which offered up the right tools. Cursor could then use those tools to automatically set up a Postgres database through Neon.
Wow.
Yeah, and in just a few minutes, the developer had a working to-do app connected to a real, live Postgres database, all orchestrated through MCP.
That really shows what's possible. But I imagine building that MCP server for Neon wasn't like a 5-minute job. Our source mentioned it's around 500 lines of code.
Yeah, exactly. It's not insignificant effort, which, leads directly to this big temptation, autogeneration.
The shortcut. Tell us about that. Why is it so appealing?
Well, most modern APIs have what's called an open API specification. It's essentially a detailed map of the API, everything it can do, what data it needs, what data it gives back.
Like a blueprint.
Exactly, a blueprint. So the really attractive idea is, why not just take that existing blueprint and have a program automatically generate the MCP server from it? Quick and easy. There are even services out there, Stainless, Speakeasy, Mitlify, that help you do just that.
Sounds almost too good to be true. An instant MCP server.
Right. What could possibly go wrong?
I sense there's a but coming.
There definitely is. While that speed is tempting, just auto-generating often leads to some pretty significant problems. Problems that can really hinder how well LLMs can actually use your service through MCP.
Okay, let's break those down. What's problem number one with just hitting the auto-generate button?
The first big issue is something we could call API overload. Think about a typical API, like Neon's. It might have, 75, maybe 100 different functions or endpoints.
That's a lot.
It is. And that's fine for a human developer, right? We can read docs, search around, figure things out. But LLMs, they tend to get really confused when they're faced with too many choices, too many tools.
Interesting. So more options aren't always better for an AI. I thought bigger context windows were solving everything.
You'd think so, but the expert insight here is that LLMs often actually perform worse when overwhelmed. They do better with a smaller, more curated set of tools. It's like decision paralysis, but for AI. So if you just auto-generate from your big API, you throw, say, 80 tools at the LLM.
Yeah.
It might struggle to pick the right one or pick the wrong one entirely. That a nickel speed gain from auto-generation, it can lead to really poor performance down the line.
Okay, that makes sense. Don't overwhelm the AI. What's the second major pitfall?
The second one is all about the descriptions. The text that explains what each API endpoint or now MCP tool actually does.
Right, the documentation bits.
Exactly. But API docs are usually written for humans. We can infer things. We can look stuff up if it's unclear. LLMs need things spelled out much more clearly. And crucially, they really need examples, concrete examples of how and when to use a specific tool.
So the way we normally write API descriptions just doesn't cut it for an LLM?
Pretty much. The Neon team found they needed to write their tool descriptions very differently. They actually use XML and focus on giving the LLM maximum context, like use this tool in this specific situation. It's way more explicit than typical API docs.
So it's like learning to write for a completely different kind of audience, an AI audience.
That's a great way to put it. And it's not just about writing it once. They talked about testing these descriptions constantly.
Testing them.
Using something called evils. Think of them like automated tests specifically for AI. They run scenarios hundreds or thousands of times to see if the LLM consistently picks the correct tool based on the description.
Okay.
And based on those evil results, they tweak the descriptions, refine the examples, iterate until the LLM gets it right almost every time.
That sounds incredibly important and something you'd completely miss with just auto-generation. Okay, what's the third problem?
The third issue gets into the sort of fundamental design philosophy of most current APIs. They're typically built for developers doing low-level stuff, right? Managing resources, automating specific granular tasks.
Like create virtual machine, update database setting, delete user, that kind of thing.
Exactly. Very specific, often infrastructure-focused actions. But that's not usually how LLMs, or even most humans, think about getting things done.
Right, we think in bigger goals.
Precisely. An LLM thinks, I need to write a blog post and publish it, not, I need to call the cretext file API, then the write content API, then the set permissions API. You know, it operates at a higher level of abstraction. It wants task-oriented tools, not just low-level resource manipulation.
And this mismatch is sort of why MCP was needed in the first place, to bridge that gap.
That's a big part of it, yeah. To give LLMs a way to interact that feels more natural to their goal-oriented way of operating, rather than forcing them to understand the nitty-gritty of every underlying API call.
Okay, so auto-generating just exposes those low-level calls, which isn't ideal. That leads us to the fourth problem you mentioned, missing opportunities. What do you mean by that?
This is where it gets really strategic, I think. If you only expose your existing API functions as MCP tools, you're basically just putting a new wrapper on old functionality. You're missing the chance to design interactions that are truly optimized for an LLM.
To build something smarter, maybe.
Exactly. The Neon example for database migrations is perfect here.
Right, database migrations. Always a bit scary. What did they do?
Well, the naive auto-generated approach might just give the LLM a single tool like run SQL command, and then you just cross your fingers and hope the LLM gets the complex migration script right and runs it safely.
Which sounds risky, especially with SQL.
Very risky.
Yeah.
So Neon didn't do that. They built purpose-built MCP tools specifically for migrations. They have one called Prepared Database Migration and another called Complete Database Migration.
Okay, that sounds much more structured. How does it work?
The Prepare tool doesn't touch the main database. It actually sets up the migration on a temporary isolated copy, like a staging branch.
Ah, smart. Like Git branching for your database.
Kinda, yeah. Then the MCP server tells the LLM, okay, it's staged, now you should probably test it out. It explicitly prompts the LLM to verify the changes.
Giving the LLM guidance.
Exactly. Then, only after the LLM, or the user guiding it, confirms everything looks good, can they use the Complete Database Migration tool to apply the changes to the actual production database.
That's so much safer. It builds in checks and balances, leveraging the LLM's ability to test, but guiding it through a safe workflow.
Precisely.
Yeah.
And that kind of multi-step, guided, safety-conscious workflow, you probably wouldn't build that as a standard REST API endpoint. But for an LLM interacting via MCP, it makes perfect sense. It's an innovation enabled by thinking specifically about the LLM interaction.
That really drives the point home. Okay, so we've heard the pitfalls of pure auto-generation. API overload, bad descriptions, low-level focus, missed opportunities. What's the recommended path forward then?
Well, the strong advice isn't necessarily never auto-generate. It's more like, don't stop there. A hybrid approach seems best.
Hybrid, meaning?
Meaning you can start by auto-generating from your OpenAPI spec. That gives you a baseline. But then comes the critical part. You have to curate it heavily.
Cut things down, refine.
Absolutely. Cut down the number of tools drastically. Remember, too much choice is bad for the LLM. So, step one, remove everything that isn't truly essential for the kinds of tasks an LLM would actually perform.
Be ruthless.
Be ruthless. Step two, Rewrite the descriptions for the tools you keep. Make them incredibly clear, LLM-friendly with examples. Test them with evils.
Right, the testing.
Step 3. Think about creating new, higher-level, task-oriented tools, like that migration example. Tools that might not even exist in your base API, but make sense for an LLM. It requires really thinking from the LLM's perspective.
So start with autogen maybe, but then prune, rewrite, innovate, and test, test, test.
That's the essence of it. It's much more involved than just clicking a button.
It really sounds like it. So the main takeaway here is that building a good MCP server, one that LLMs can actually use effectively, isn't just about automation. It's about thoughtful design, curation, and really understanding the mind of the LLM, so to speak.
Couldn't have said it better myself. It's about shifting our focus from just exposing raw API functions to crafting clear, concise, goal-oriented tools with descriptions tailored for AI comprehension.
This whole conversation really makes you wonder, doesn't it? As these LLM interactions become more common, how fundamentally will this change how we design our applications? Are we moving past just listing API endpoints?
It feels like we might be. Towards designing more guided experiences, more task-focused interfaces, built specifically for AI agents to use.
What kinds of completely new things could that unlock? New ways for AI to help us, maybe? It's definitely something interesting to think about. Now, this has been a fascinating deep dive. Thanks for walking us through it.
My pleasure. It's a really exciting space right now.